Hello everyone, it's Jay, and today we'll be doing problem 1 on the pre-workshop. So we're told that acetone, and we're given its molecular formula, combusts in the presence of oxygen gas. And we want to know how many grams of O2 are used in the complete combustion of 20 grams of acetone. Alright, so we've highlighted our important information, and it's important to note that this question does kind of look like a bubble diagram question as we have combustion. And you definitely could do it with a bubble diagram. It would actually be the exact same thought process as doing it with an ice table, but we'll be using the ice table because that is the concept that we are teaching for this week. So know that you can do it either way. So we're going to start by taking our equation. So we know that we have C3H6O reacts with O2, and we get combustion. So we know that the products of a combustion reaction are CO2 plus H2O. And now we're going to balance the equation in order to use our ice table. If you need help with balancing, I recommend that you go back to the week 5 balancing videos. I'm going to balance it quickly off camera. Alright, so we've got the reaction all balanced, and now let's fill in our ice table. So we have our initial line, we have our change line, we have our end line. Alright, so what information are we given? We're given that we have 20 grams of acetone. But in this course, when we use ice tables, we always want to be working in moles. So let's convert that to the number of moles. So we have 20 grams times 1 mole of acetone, or the molecular mass, is 58.08 grams. And we get that we have 0.344 moles of acetone. Great, so we can fill that in. Now, while it might not seem like it initially, we actually are given another piece of information to fill out our ice table. Namely, we're told that there is a complete combustion of that acetone. So we know that we end with 0 moles of acetone. So we know that our change in moles, we go from 0.344 to 0 moles, so we have a reduction of 0.344 moles. So if we know that the acetone changes by a decrease of 0.344 moles, then we know the change in our oxygen, because oxygen is in a molar ratio of 4 to 1 when it comes to oxygen to acetone, we know that our oxygen decreases by 4 times as much. And if we do that calculation, we get that we have a reduction of 1.376 moles. So, therefore, we know that we use 1.376 moles of O2. If we convert that to grams using the molar mass, so O2 has a molar mass of 31.9985 grams per mole, we get that we have 44.03 grams of O2 that are used up in the process of this reaction. Thank you so much for watching.